In this video, I will be talking about arrows in Haskell. The point of this video is to explain the purpose of the arrows and to give examples of how to use them. Arrows are a structure representing an abstract sense of computation, specifically focusing on composition. They serve much the same purpose as monads, providing a common structure for libraries, but arrows are a lot more general. A computation takes inputs of some type and produces outputs of another type. So as you can see, arrows are very similar to simple functions. Arrow has category as a superclass. Category is a class for things that can be composed like functions. We will look at the type classes for arrows with the arrow methods. The minimal definition only needs two of them, r and first. The first one, r, is used in order to lift an ordinary function into an arrow context. The other functions are used for composition. So let's take a closer look. R is our basic building block. R turns a function into an arrow, composable with other arrows. Naturally, not all arrows are created in this way. First takes two inputs side by side. The first one is modified using an arrow, while the second is left unchanged. Almost same as the first, the second function takes two inputs but only modifies the second one. The triple star is the combination of the first and second. Triple star takes two inputs and modifies them with two arrows, one for each input. And then lastly, the triple end takes one input, duplicates it, and modifies each copy with a different arrow. It is quite common to see arrow combination being used in code that otherwise has nothing to do with arrows. Here's a summary of what they do with plain functions. Now I want to show you a practical example. We'll use the arrow type class to build a small computation. Imagine we have two functions that process numbers, double and increment. But now we want to create a pipeline where we first double a number and then we increment it. Using functions, we normally do something like this. Result is increment double 5. But now let's see how we can do the same thing with arrows. Here we use the R function to lift our functions into arrows and the three dashes to compose them. You can also pass through extra data using the first function, which applies an arrow to a part of a tuple, like in the function process tuple. This shows how you can handle multiple data streams in parallel, something that monads don't handle as clearly. So now let's look at the main function. First, we're applying process arrow. Process is an arrow that combines the two functions, double, which multiplies the number by 2, and increment, which increases the number by 1. So process 5 means we're applying the process arrow to the input 5. So input 5 first passes through the double function, resulting in 10. Then this result is passed to the increment function, which gives it 11. So the result is 11. So let's look at the second part of main. We're applying the process tuple arrow. The first part doubles the first element of the tuple, and then the second part modifies both elements of the tuple. It increments the first element by 1 and the second element by 2. When we pass the tuple 3.4 to process tuple, the first function applies double to the first element, so 3.4 becomes 6.4. Then the lambda function is applied, which adds 1 to the first element, so 6 plus 1 is 7, and adds 2 to the second element, so 4 plus 2 is 6. So the final tuple becomes 7.6. I also want to talk about Kleisli arrows. Kleisli arrows help us compose functions that produce monadic results. Normally, a function in Haskell looks like this. It takes a value of type A and returns a value of type B. But when you're working with monads, the return type of our function is inside a monad, like this. This means G takes a value of type A and returns a value of type B that's wrapped in a monad M. An example with the maybe monad, G could look like this. Now let's say we want to combine two such functions. I wrote down these two functions, but as you can see, we cannot combine them with normal function composition, because the outputs are wrapped in a monad. Here is where Kleisli arrows come to the rescue. Kleisli arrows allow us to compose these monadic functions. They handle the monad wrapping in a way that keeps everything neat. In Haskell, there is a special operator for composing Kleisli arrows, called the Kleisli composition operator. It lets us chain functions of type A to MB and B to MC together into a single function. Let's give you an example of Kleisli arrows. Let's say we have these two functions using the maybe monad. Function g takes an int and returns a maybe string. If the number is positive, it wraps the string version of the number in just, otherwise it returns nothing. Function h takes a string and returns a maybe int, based on the string's length. Now we can make a function to combine g and h using the Kleisli composition operator. Combine is a new function that takes an integer and returns a maybe integer. It ensures that if g returns nothing, the entire computation returns nothing, without even calling h. If g returns just something, that something is passed to h. This composition allows us to handle monadic values smoothly. Now let's see this action with our main function. I'll go through each print statement to understand the output. So first we print combined 5. So then you have to apply g to 5. So g5 checks if 5 is greater than 0, which is true. So g5 is just 5. Then apply h to 5. h5 checks if the length of 5 is greater than 2. Well, the length of 5 is just 1, which is not greater than 2. So h5 is just nothing. So the result is nothing. So now for the second example, we did combined minus 1. So first apply g to minus 1. It checks if minus 1 is greater than 0, which is false. So g minus 1 is nothing. And since g minus 1 is nothing, h is not even called. So then combined minus 1 is nothing. So now for the last example, we do combined 123. So first, g123 checks if 123 is greater than 0, which is true. So g123 is just 123. Then apply h to 123. It checks if the length is greater than 2, and the length of 123 is 3, so it's greater than 2. So h123 is just 3. And since both g and h returned just values, combined 123 is just 3. So that's why the output is just 3. And for comparison, here you can see how you can achieve the same functionality without using Kleisli's arrows. You can see that it takes a lot more lines if you don't use the Kleisli arrows. So we saw how arrows allow us to compose complex transformations step by step, making our code more modular and easier to understand. So let's finish with an important question. When should you use arrows? Well, we know that arrows shine in situations where parallel computations are involved, or when you need multiple input-output streams, or when you can't rely on strict sequencing that monads require. So if you ever find yourself working with computations where you can't or don't want to use monads, or where input and outputs are more complex, consider arrows. Thank you so much for watching this video. I hope this video gave you a clearer understanding of how to use arrows in Haskell.